Okay, I uploaded the ellipses. Now I'm going to work on hyperbolas. And while it was uploading, I looked at the PowerPoint and I found where I did not finish the application of Mars and the distance from the sun. There's a couple small steps that I did not continue with. I jumped to conclusions. I had my answer, but it's what I get for rushing. But go ahead, you find the mistake. It's good for you anyway. The kidney stone problem, or yeah, was right on the money, so we're good on that. Let's look at the last conic section. Yeah, we've done circles a long time ago. We did parabolas this week. I just got done lecturing ellipses. Now I'm doing hyperbolas. Picture staring at you. Interesting thing about a hyperbola. If you move this piece to the, how can I put it? It's actually related to the ellipse, because what's going to happen is we still have our distance going. Let me get another color here. A color would help. Oh, there it goes. I like to think, why is it not wanting to draw? Oh, my pencil is there. I like to draw a rectangle and realize that, and I might have gone too far. Well, it's close enough. And inside this hyperbola, you're going to see that if I thought it was an ellipse problem, if I was graphing an ellipse and the ellipse went like this with the same values, you'll see what I'm talking about. But anyway, the ellipse would go inside this box, and here are your vertices. What happens is if you were to draw from the center, which in this case is the origin, and I draw like a imaginary line that goes on forever from the vertex to the corner of the box, the hyperbola actually rides that asymptotically, never crosses it. It's why it's not a parabola. People look at hyperbola and think, well, isn't it just parabola? There's just two of them. No, because what happens, it may look parabolic at the beginning here, but as it goes to infinity, it gets straight, like a straight line. Think of a meteorite coming to hit the Earth. Here it comes. Here it comes. It's going to hit the Earth. It's going to hit the Earth. And it's going straight to the Earth. All of a sudden, the gravitational pull and of maybe the sun that's behind it, and maybe there's some dampening from uh, the acceleration is going to be, it's going to be grabbed and it's going to slingshot out away from our. We happen to think that that happens a lot, that things come at us and they don't ever hit us. They just get slingshotted away from us, hopefully. But anyway, that's hyperbola. It has a focus, it has two of them, but they're inside the hyperbola as opposed to being inside the ellipse here. And it does have a center, but the center is between the two vertices. Okay? And the two vertices, it still is an a distance, negative a distance. That's a positive a distance, just like we did with ellipses. Now, the b is really not in this problem per se, because we never look at that distance or that distance. But it does have a focus, okay? Which again, minus c left, we're at 0. 0 minus c takes you minus c. 0 plus c takes you to c. So we still have that. And there should be another terminology. Yes, yes, yes. The axis that is cuts the hyperbola exactly in half, where both pieces are on each side, is called a transverse axis. And it goes through, in this case, possibly 0, 0, but whatever the center is, it goes through wherever the x-coordinate. And yes, hyperbolas will be also the other way around. So let's see. Let's do the fancy definition. A hyperbola is the, you notice this, all of these conic sections said a blank is a set of all the points in a plane such that, well, it's the same kind of talk, but listen to it. It's the set of all points in a plane such that the absolute value of the difference, not the sums this time. We are going to subtract, and it doesn't matter which goes first because it's absolute value anyway. A negative 5 versus 5 is still going to be 5, absolute value of. And so of the distance between two fixed points is constant. The two fixed points are called the, you got it, foci of the hyperbola. So if you look at that particular picture, and sometimes I think I just talk too much, so I don't know. If you look at this picture, here's a focus point. Okay, he did us a favor. He actually drew to a point on the hyperbola over here, okay, to that focus point. Then he also connected that same point to the other focus point. So now if you take the difference, whether you take the big minus the small or the small minus the big, it doesn't matter. You're still doing the absolute value of that distance. It'll always be the same, no matter what point you pick. If I pick this point here, let me do another color, this point here, and go the distance from here, this focus, and then to this focus, that difference is the same as the red difference. I could pick a point way out here and do the distance to this focus, and then the distance to this focus, and subtract those distances will be the same exact difference. It's a miracle of hyperbolas. Okay. Sketching, what you'll notice that this is the standard form. I'm not going to go through the proof of where the equation came from because it's long and drawn out. But what I will tell you is that there's a minus instead of a plus. But what I do in my head, this is what I do in my head. I say, self, well, what does the ellipse look like? What if it was a plus? I told you I draw that rectangular box. So here what I'm going to do, I can tell that the center is 0, 0. So here I go. I'm going to put my center 0, 0 here. And it's going to be, if I'm doing an ellipse, it's going to be a horizontal ellipse. A vertical ellipse because 49 is bigger than 25. So the square root of 49 is 7. So I'm going to go up 7. I'm going to go down 7. And then the other number was a 25, so I'm going to go to the right 5. 0 plus 5 is 5. 0 minus 5 is a negative 5. And what I do is I make my invisible rectangular box. I saw one teacher, I'm going to post the video in the plan for you to see another teacher. He did it this way too. I've always done it this way. And then my ellipse is going to be inside, and I'm just going to make it a light picture because the ellipse doesn't really exist. There's my ellipse. And so the ellipse fits in the box. And then I go ahead and I say the asymptote of the hyperbola goes from the center to the corner of the rectangular box. Okay, stare at that for a couple minutes. So if you really, really, really want to study this even more, go ahead and look at that PowerPoint. They derive the formulas. I used to cover it, but, So I need to point out to you that the minus sign is on the y. That implies that the transverse axis has to be an imaginary line that connects the vertices and the foci of your hyperbola. So since I've already decided that the y has the negative, that tells me that, to me, your hyperbola is going to look like that. Just pretend that the y-axis is in the middle, okay? Now, if your center moves, that's not always true. But just picture empty space that a vertical line would go through, okay? All the way through. So I'm going to go to find my vertex right here. I'll call that vertex 2, since on the right side is at negative 5, 0, because 0 plus 5, what did I say, negative 5? That one's positive 5, 0. This one over here, I'll call vertex 1, is the negative 5, 0. Okay? And then that would mean my focus. Did he want me to do foci in here? Yeah, find the vertices and foci. Foci, c squared is equal to a squared plus b squared for hyperbola. So it doesn't even matter which one is a and b. You're still going to go c squared is 25 plus the 49. That c squared is 40, 50, 60, 69. What did I just say? 69, 74. And so c is going to be plus or minus the square root of 74. And why is it plus or minus? Because you go to the center, which is starting at the x value of 0, and I have to go left and right from that 0. Square root of 74 is less than the square root of 81, which is 9, and bigger than the square root of 64, which is 8, between 8 and 9. So I go and I count between 8 and 9, and I'm going to call this one foci number 2, which is at square root of 74 comma 0. And this foci here between negative 8 and negative 9 is foci number 1, which is negative square root of 74 comma 0. And this imaginary line is called the transversal. It connects those 4 points imaginary. Now, I haven't graphed a picture yet. Here it goes. Let me do it in red. What you want to do is you go to the vertex. You want to try to make it a curve, but as it gets closer to the asymptote, it curves, and what it does is it gets linear. Okay? Again, go out as smooth curve as you can get to the asymptote, and then straighten it out. Okay? Straighten it out. Straighten it out. You can do better than me. Come on. Okay? So there is my picture. He wants domain and range. Now that is a little different for this. The domain, if you look carefully, let me put a shading yellow here. There's no x's being used between the two vertices. So what you're going to have is negative infinity all the way to the left x value of that vertex. Did I label those vertices? Yeah, I did. It was a negative 5 comma 0. So all the way to a negative 5. Union, pick back up at 5 and go to infinity. And if you really want to be honest, you can go included the negative 5, including the 5. Because in the range, well, it doesn't matter if you go which side. It goes up and up and up forever and ever. It goes down and down forever and ever. So we can say negative infinity to infinity. Or you can say all real numbers. All right, so there is, let's match this one up. Let me make sure it's at least matching. Thank you. Okay, now he's showing us. Thank you. About time. He's got the negative on the y squared just like I did. And he didn't give it a name. He just says the transverse axis on the x-axis. You know what? Maybe I said something wrong on the other page. I'm wrong. The transverse axis goes to the vertices and the foci points. All right. So it's still vertical though. Still vertical. I flipped it. All right. Sorry guys. It's been a long time. Any important notes in here? Oh, he gave you the equation of the asymptote because if it goes through 0, 0, all he needed to know what the slope was. So he found the slope between these 2 points of this and that box of that rectangle, the fundamental rectangle. He found that slope to be a positive something. Well, he's just telling you positive something. And so what's different about okay, look at this. Minus the x squared. So now your vertices are on the y-axis, your vertices are on the y, and so the middle of it now is the x-axis, and he's calling the, I'm sorry, I now I do completely remember that the transverse axis connects all 4 of those points. There is your formula for the focus point. The same formula here, doesn't matter what A or B is. All right, at least my graph was right. I just, because you don't really graph the transverse axis. I do understand. I might go and edit that one. Well, if I'm telling you I was wrong. Okay, I was wrong on another slide, and you may not have known it because I'm going to go fix it. Anyway, before I post it. Graph this hyperbola. Let's see. I don't have a 1. I need a 1. So let me go ahead and divide everything by the 100 to get that 100, to get that 1 over there. And so 100 divided by 25 is a 4. So it's y squared over 4 minus 100 divided by 4 is a 25 in the number. So that's x squared over 25 equals to 1. So it doesn't matter. Call A equals to 2 because 2 squared is 4. Call B equals to 5 because 5 squared is 25. C, may as well we're at it, will be these 2 numbers, A squared plus B squared. That's the 29. C squared is 29. Take the square root. C is plus or minus the square root of 29. I'm not moving this hyperbola. The center is still 0, 0. But I will notice that the x has the negative. So this is going to be what I would call a horizontal, only because the thing opens up and down. So I call that horizontal. I don't know if that's ever been called in a book. I can't remember. So the big number, 25, is on the negative x squared. Well, again, this gets kind of confusing because I want to say to myself, well, how do I graph it? I'm going to do the same thing I did before. I'm going to say the square root of, well, in the ellipse, we keep the big number is the a. So I say square root of 25 is 5. Well, I already have it. So I'm going to go, well, we'll see if it looks good or not. If I go 5 and negative 5, and I do the square root of the 4, which is 2 and 2, 2 and 2, that doesn't help you very much to know if it's vertical or not. That is irrelevant. Now, let's look at my rectangle. Because you have to ask yourself, could this be a correct orientation of my A's and B's? And I'm going to tell you it's not right because underneath the y is the 4. So that's 2 squared. So the y, the vertical, had to be the 2. So you see the difference? I did have that. Never mind, I'm right. 2 and 2. The vertical has the 2. And the x has the, it was a 25, so 5, 5. So it is correct. And so look at where those numbers, what are they under? What variable? Go ahead and make your transversal. Whoop, that's not very straight. You don't have to draw the ellipse like I did before. You can. I mean, for sure, if you don't draw it, you still got to realize that the vertex is going to be here and here. So whether you draw it or not, that may help you. You see, I'm doing a very light color. And I said this opens up or down because the negative is on the x, meaning pretend that the x-axis is in the land of no man's land. There's nothing in there, okay? Because it's going to open up like this. Let me get a darker color yellow. Here goes. Here goes. Oh, it's not yellow. That way. That way. That way. That way. And yes, you should always, this time he's asking for, give the equations of the asymptotes. He wants you to say where the foci and the domain and range again. So let's do one of these and see if we're right. I'm going to use 2 ordered pairs. 0, 0 is the center, so always grab the center. Grab one vertex of the rectangle that I drew. I'm going to go 5, negative 2. 5, negative 2. So therefore, I should be getting this asymptote here, which, by the way, my hyperbola is way off. I should have really done a better job at getting it to follow this asymptote. Once it comes around, it should really follow that really close. So I'm not a very good artist. Let's get the slope, because the center is 0, 0. So you know it's just going to be y equals some sort of ax. Or no, I shouldn't use a. Well, I could use b over a. That's your slope. But anyway, some number. Call it k. Call it m. Whatever you want to call it. M, slope. So 0, so slope is 0 minus 2 over 0 minus 5. Sure enough, negative 2/5 is the equation of this asymptote. That's that one. Because I used this point in the center, so obviously it's a negative slope. What do you think the other asymptote is? Give you 30 guesses. I hope that if you say y equals negative 2/5 x for one asymptote, the other asymptote I'm hoping is positive 2/5 x. And let's just try it. Let's use the 0, 0. And we'll use this ordered pair, which is 5, 2. 0, 0 and 5, 2. Let's see what the slope is. 0 minus 2 over 0 minus 0 minus 2, 0 minus 5, and it becomes 2/5. Yeah, I was right. Okay, so there are my asymptotes. Label them. Asymptotes. It's harder when it's not centered at 0, 0, of course. Oh, domain and range. Okay, domain. Get this now. Domain. All real numbers. Or you can say from negative infinity to infinity, right? Because it goes left forever, right forever. Even though it's going down, it's still left and right. The range this time has the gap. The range has the gap. So the range this time would be negative infinity coming straight up. And where's that vertex? That vertex is at 0, negative 2. So negative 2 is the lowest there. And then it picks up. So I go union, pick back up at 2, and go to infinity. Next one. Okay, fine. We're going to move it around. What changes? H and K again. H and K, opposite of H, that's left and right, opposite of K, up and down. The transverse axis, okay, let me get the definition right. Transverse axis is horizontal. Interesting. The axis is horizontal, but I was calling that a vertical hyperbola. I still want to call it a vertical hyperbola because the graph is vertical. The transverse axis doesn't really exist. There's no line. There's no line that connects them. It's imaginary. Okay. Vertices. Okay, for this one here, you know I've got to go from the zero, or the zero, which is the center. So that's HK, just like it was in the other problem. So the center X value is H. Now I got to add to it A. HA. How high do I go? Whatever K is. So I'm going to say the vertex for this one is H. You could say plus or minus A, both of them, comma K. Whatever K is, that's how high it goes. Two of them, plus or minus, whatever that is, there's two of them. The foci will be whatever H is, plus the distance till you get to the focus, which is called C. So, very similar. H plus or minus the C, comma K. Asymptotes, that's going to be kind of a little more difficult to have the equation of the asymptote. I don't even know if I want to put one there. Let me just think on that for a second. Asymptote. How am I going to have a simple generic? If you, in this problem, my slope of that line was B over A, because when I graphed my hyperbola, if A squared and B squared is here, so I know that I was going rise over run, which was my B over A to get to that box there. So I'm going to put, well, the slope can be both directions. So y equals plus or minus B over A, and x minus h, because the h is connected. And then always going to shift it to the k. The only thing difference with what I call the horizontal hyperbola, which has the vertical transversal, so vertical transversal, I still call that a horizontal hyperbola. Vertices are now, the H is locked in, but the K is being used from the center. But whatever H is, you lock it in for all three of these. So my vertices will be, H is constant, but now I go to my K plus or minus, not K, yeah, K plus or minus, what did I write up there? Well, is B, plus or minus B, I believe. The B number. And I think he stays consistent. Never mind. Plus or minus A. In the focus, H is constant. K plus or minus C. Asymptotes, the slope switches the rise over the run now. So y will be equal to plus or minus, instead of B over A, it's A over B. It's still X minus H, and it's still going to be plus the K. Personally, guys, I don't memorize these very well. It's, to me, so much easier just to find the center, find the corner of the box, find the equation of that line, and then realize, guys, what's going to happen is whatever you get here, it's not going to be the same value. The y-intercept's different. So you need to find the equation of the line and then the equation of that line. They're two different lines. It's not as easy when it's zero as it was with 0, 0. All right, so let's graph a hyperbola translated away from the origin. Okay, so here goes. What did I say? If the x is being, get the negative, is that going to be a horizontal in my book or a vertical? Okay, if you have to have a cheat sheet at first, it's okay. When the x was being with a minus, that told me that there is a blank line in the middle of it with nothing there, and it's horizontal. That means the hyperbola has to be opening up and down. That's how I try to memorize it. That if the x is being negative, then the hyperbola has to be up and down. You know, pretend that the center is at 0, 0. Then it has to open up and down from 0, 0. So that's what's happening here. And as I said, I may as well try to draw my rectangle or my ellipse. And the y has 9 down here. So the y is going to be up here at 3 and a negative 3. Wait, I got to get the center. Hello. My center, sorry. HK is negative 3 and negative 2. Opposite, opposite. H stays with the x. So before I draw that point right there, which was just me getting ahead of myself and getting excited, is find that center. Negative 3, negative 2. Negative 3, negative 2. Now, pretend that is the same thing as 0, 0. If I need to go 3 on the y, from the center, I will count 3. 1, 2, 3. 1, 2, 3. And then for the other one was 2. So I go to the center. 1, 2. 1, 2. And there's my box. Let me use the yellow now. There's my rectangle that I will use. Okay. And I told you it's going to open up and down. So I'll make that little note to myself and realize that that's a vertex and that's a vertex. So let me label my vertices. My vertex 1, I'll call this vertex 1. I'll call this vertex 2. Vertex 1 is obviously negative 3, 1, if I did the math right. Vertex 2, negative 3, negative 5. Just by looking at the picture. Draw my asymptotes to the corner of this box and beyond. To the corner of this box and beyond. Beyond. You got the idea? So then go back to where I know how it's opening, and let's try to do a better picture this time. Let me curve it up till I get close, and I want to ride the asymptote forever and ever. And remember, never crosses the asymptote. Just gets closer and closer. There it is. There it goes. What am I missing? What else did he want? Graph it, give the equation of the asymptotes and the domain range. So he wants the equation of those asymptotes. So my center was negative 3, negative 2. I'm going to grab this ordered pair, which is negative 1, 1. Negative 1, 1. Then I'm going to do the negative 3, negative 2, and do the other line. So I'm going to take negative 1, negative 5, it looks like. Negative 1, negative 5. Make two equations. So asymptote 1. Here goes. How do I do it? Slope between... do this equation. Y, you know you learned it for a reason. Y minus y1 equals the slope times x minus x1. The slope would be a negative 2 minus 1, negative 3. Negative 3 minus minus 1 would be a plus 1. That's a negative 2. That's a 3/2. Well, I expected it to be positive because I did these 2 points, so it should be positive. So 3/2. So here goes. Y minus, pick a point. I'll pick the center. Y minus the, it was a negative 2, right? Negative 2 minus 1, yeah. Is a negative 2. Minus minus 2 is plus 2 equals the slope of 3/2 times x minus minus 3, which is x plus 3. That's a perfectly good equation. I personally would leave that answer, but if you're doing My Math Lab or something, they probably solve it for y. So to solve it for y equals to 3/2 times the x plus 3. Probably I'll do that plus 3. Oh yeah, he just does the minus 2 over here. Plus the k, remember? The k was a negative 2. That works. And then the other one, I'm taking a guess. The second one will be, if I said it right, should be the opposite sign. Instead of 3/2, should be 2/3. It still should be x plus 3, and it still should be a minus 2. Let's see if I'm right. Find the slope. Negative 2 minus minus 5 is negative 2 plus 5, which is 3. Ooh. Negative 3 minus minus 1 is a plus, that's a negative 2. Well, 3/2. What did I put over here? Huh. I had 3/2 here. Was that right before? Maybe I wrote something wrong on the other page. I thought it flipped. Check the PowerPoint. See if it flipped it, because I just did the math. That's why I told you I don't use formulas. Just do the work. Just find the slope of the line. And then let's see. Let's do the y minus y1 equals the slope times x minus x1. Just do it. I'll pick the center again. That was a negative 3, negative 2. So y minus minus 2 is y plus 2. And then I got a negative 3/2 slope. And x minus x1, well, that would be the x1 was minus 3 as plus 3. So it's the same. And the slope was just the opposite sign. Well, that to me makes more sense. Where did I write? Oh, I wrote it up here. Let me go look at what the PowerPoint put, and I'll paste it up in here and see if I'm just did I just thought that's what's supposed to be? I'll be right back. Never mind, I was right. It's when you switch it to the vertical hyperbola or the horizontal hyperbola. So for this problem, I need to keep it's one hyperbola. I keep the same slope. Hello, 3/2 and a negative 3/2. It's if I was changing it to the vertical hyperbola, then that slope would be opposite of what if I was changing the negative to be with the other one. All right, okay, I was right, but yet I was thinking of two different hyperbolas. I'll take it and run. Let's go on. All right, reflection. How do you determine with hyperbola as a vertical transverse axis that's up and down versus a horizontal transverse axis? If you recall what I said, if it opens up and down, we know that's a vertical transverse axis because the vertex, the focus, the vertex, the focus create an invisible axis, okay? And that meant you have the minus x, the x is getting the minus, okay? So minus x, whatever it's under, some number, a squared. So that tells me that the hyperbola has this blank, pretend it's the x-axis in the middle if it was centered at 0, 0. Not centered at 0, 0, but yeah, that would be the center. That's how I remember it. And thus, if the y has the value, that means the y is kind of like in the middle of the two pieces, so it's going to be, to me, I call that vertical, and I call this one a horizontal. Vertical because I suppose the invisible line that cuts it in half is vertical. The visible line that cuts it in half is horizontal. So that's what I call them. All right, eccentricity. Narrow hyperbolas have an eccentricity near a 1. Near a 1. The more narrower that it is. And wide hyperbolas have eccentricity. I'm going to say large eccentricity. That would mean greater than 1 for sure, okay? A lot greater than 1. The smaller it is, eccentricity has to be between 1. So it has to be greater than 1. And technically, it can still be, it's got to be less than infinity, of course. But you can't have I can't, better not say never. The larger it is tells you that it's a more wider. The skinnier, this would be skinny. Okay, see this one right here is very skinny. That eccentricity is close to 1. This one's really wide, so it's going to have a larger eccentricity. Oh, look at what was his. E. He said E is 5. Oh, yeah, I guess that's wider. Hello, it's almost making a straight line, so it's not skinny. Where's the skinny one? This would be how it's closing, so it's getting skinny. It's skinny, getting fatter, so fat that it looks almost like 2 lines. Okay. You can get bigger and bigger. I don't know what the biggest you can get. That looks pretty. I don't think you're going to get infinity. I don't think you can get 10. Formula for eccentricity is still C over A. Okay? And remember, C squared is A squared plus B squared. Find the eccentricity. Okay. Well, I just got done asking you what we would do. C squared would have to be A squared plus B squared, whichever one is A. Doesn't matter really in this case. 9 plus 4, that's a 13. C is square root of 13. And write the equation of hyperbola. Wow, that does get a little harder to write the equation, and all he's given me was 2 focal points. And he's given me E is 2. So if E is C over A, I can use this to get A because C, if I graph those 2 points, -9, 5 here, and the other focus is at -3, 5. That's the other focus. So what's the distance between those? The distance between them, -9 and -3, is 6. So that tells me that the center is exactly in the middle of it. So between -9 minus 3, minus 3, is a -6 divided by, let's see, that won't work. How am I get the middle of it? The middle is at a -6, right? 3, 4, 5, 6, yes, -6. That tells me that this distance here is 3 distance. So that would tell me my A is 3. And if E is 2, so 2 equals to, oh, well, I can tell you what. C goes from the center to the focus. Sorry. C is 3. Sorry, C is 3. So 2 is 3 over A. That I don't know, because I don't know where the vertex is. I went to the focus. I didn't go to the vertex somewhere in there. Yeah. So that would give me A would have to be 3/2. Okay, well, that's fun. Okay, and I know that C squared is A squared plus B squared. So C squared, which is, C is 3, 9, equals to, obviously A is 3/2, so 3/2 squared is 9/4 plus B squared. I got to solve it for what the B squared is. So I know A squared will be 9/4. That's important. Keep that in mind. So B squared, let's see, 9 minus 9/4 is B squared. 9 is the same as 36/4 minus 9/4. That's 27/4, isn't it? 27, yes, equals to B squared. So my equation of my hyperbola, I need the center, I need HK. HK, I said, was a -6. It'd be a -6, 5. -6 is in the middle here, up 5. So HK, -6, comma, 5. And since my transverse axis is horizontal, then I know I call this a vertical hyperbola, which means the y is getting the negative. So x minus 6 is x plus 6 squared minus the y minus 5 squared equals to the 1. And the numbers I'll put underneath are what was my a squared? A squared was, I labeled it somewhere. Oh, right here, 9/4. 9/4 is my a squared. My b squared was 27/4. Could we write that differently? You could. You could actually flip this 4, put the 4 on top over 9, minus put the 4 on top over 27. Okay. I'll take it. I'll take that answer. see, to do everything on here. Example. Oh, hello. Find the eccentricity. I only found C. Eccentricity is C over A. Sorry, I didn't finish it. So I'm glad I went and looked. Square root of 13. And A was my 3. Okay, square root of 9. Square root of 13 over 3 is the eccentricity of that particular equation. And calculator will probably give you a decimal, but I don't really care about the decimal answer. Okay, I'm done. Yay, I'm done. Okay. Have a great one.